What is the truth in the stories we are told? We've been given a story of a world fueled by separation. We've become separate from one another, separate from the earth, ultimately separate from the true nature of ourselves. It's time we learn the truth. It's time you rewrite your story. It's time to realign with who it is that you really are. This is the fifth dimension.
You are infinite and eternal. We are infinite and eternal.
Our natural essence, we could say, is simply being.
We have this awakening coming together as a perfect storm.
We're ready for this. We have the capacity inside. We just got to find that.
Okay.
All right, and we are on the air. I want to welcome everybody into the Fifth Dimension podcast. And for today's guest, I am joined by Dr. Michio Kaku, who is a theoretical physicist and author of many books, but particularly the new book, which we're going to talk about, The God Equation, the quest for a theory of everything. Michio, thank you so much for taking the time to come on the podcast.
My pleasure.
Yeah, it's absolutely an honor to have you on. I sort of grew up watching your work, following, the programs you're on. So you're sort of one of my childhood scientists, along with like Bill Nye, I guess you could say. So I'd love to start if you could just sort of introduce this idea of, what is the God equation for people, who don't sort of have this, a background in string theory or really understand what it is that you're looking to bring out, with this book.
Well, it all started when I was 8 years old. When I was 8 years old, I still remember that all the newspapers were talking about a fact that a great scientist had just died, and they put a picture of his desk on the front page of the newspaper with a book. The book was unopened. The book was opened, and the caption said, "The greatest scientist of our time could not finish this book." Well, I was fascinated. What? A great scientist could not finish that book? What's so hard? Why couldn't he ask his mother? What is so hard that he couldn't finish this book? So over the years, I went to the library and I found out the man's name was Albert Einstein. Well, today I work on something called string theory, which we think is the leading candidate, in fact, the only candidate for this fabled theory. So think of the universe as a chess game. For 2,000 years, we've watched nature and we figured out how the pawns move and maybe a bishop or a knight. But the ball of wax, the whole name of the game, the destiny of the human species, I think, is to first find the rules of this chess game. That is the God equation, and then become a grand master at it. So I think that's the destiny of humanity. The humanity itself is tied to creating a theory of everything. Now, biology can be summarized in the language of chemistry. Chemistry, in turn, can be summarized in the language of physics. Physics, in turn, can be summarized by the theory of the very big, like relativity, black holes, big bangs, and the theory of the very small, like atomic physics, the quantum theory. But to put them together is the whole ball of wax. To put them together would be the crowning achievement of 2,000 years of science, ever since the Greeks asked the question, what is the world made of? So that's what I do for a living.
Right. No, and the book was fantastic. And I feel like you really outlined the ways in this is actually possible, because when we talk about the idea of like proving this almost unseen force that unifies everything, that's interconnecting like web. That it seems like a daunting task. And I think this is where the idea of like God comes in, right? This unseen force. And I'd love to ask as well, sort of as we dive into this conversation, when we say the word God, like for you, like what does that like entail when we say God, or like and how does sort of your philosophy or belief system impact how you approach this problem, and maybe how others are approaching this problem as well? Because I know there's certain connotations that come with the word God in particular.
Well, Einstein once said that science without religion is lame,
Hmm.
but religion without science is blind.
Hmm.
So, and of course, Einstein had his own opinion. He did not necessarily believe in a personal God that answers your prayers, that gives you that bicycle that you wanted for Christmas, that smites the Philistines. Einstein did not believe in that personal God that answers your prayers, but he did believe in the God of order, simplicity, elegance, the God of Spinoza. You know, the universe didn't have to be this way. The universe could have been ugly, messy, chaotic, without anybody in it, just a mass of electrons and neutrinos and subatomic particles. But here we are. We are conscious beings contemplating how simple the universe actually is. You realize that on one sheet of paper, I can write down all the known laws of physics. Now, of course, we want to get it down to 1 inch,
Right.
but my equation, I'm the co-founder of string field theory, for example. My equation is about 2 inches long, and it summarizes all of string theory, but it's not enough. We want to get it down to 1 inch to be able to explain membranes as well as strings. But the point I'm raising is Einstein thought that he was like a child entering a library, this huge library of books. And all he could do was open the first book and the first page of the first book. But he knew that in front of him was this enormous library of knowledge. So that's how he approached the universe. The universe is simpler than it had to be. It is more beautiful than it had to be. Could have been chaotic, could have been random. But here we are in a gorgeous universe where the laws can be written down on a sheet of paper.
Right. No, definitely. And, when I personally think of the idea of God, like I don't come from a religious background per se, but it's sort of like, for me, it's like the question of what almost caused the universe and what sort of came first. Was it just inanimate like matter that has no life to it and like atoms and particles, or was there like some sort of consciousness that preceded that? And it doesn't necessarily mean like, when we think of God, like a person, a being, an entity per se, but it might be more of like a life force that maybe permeates all of different, all parts of everything. And I think that can really explain, in theory, the God equation. Because as I was reading your book, I myself, I'm in a few different like spiritual circles and have sort of my own sort of spiritual perspective on the world, and it was very intertwining with a lot of sort of some of the truths I see many people practicing nowadays, particularly in spiritual communities, about the ability to manifest a reality and interact with sort of a quantum sphere and different dimensional planes. So there's a whole lot of interlocking or intertwining entities that I'm seeing from science in religion or spirituality that are really um, coming to a head right now. So, you know, with like the God equation, is it ultimately going to be something that is viewed more in a philosophical lens, like when we're talking about the God equation, and what is sort of like, how do we move forward with like the current scientific method in that, because it is very much from a material standpoint.
By the way.
Oh, did it freeze up?
Yeah. So could you just repeat the question?
Yeah, definitely. So like when we're looking at like the God equation, and we are seeing sort of this like almost intertwining of science, with the scientific method, and starting to dive into like philosophy and spirituality and these like esoteric concepts, how are we able to actually potentially like observe or experiment and measure something like a God equation when it almost falls outside of currently the ability to perceive it, because our sensory perception is in such a limited like bandwidth?
Well, my parents were Buddhists.
Mm.
And in Buddhism, there is only nirvana. The universe is infinitely old. It stretches in all directions in a sphere called nirvana. But as a child, I was raised as a Presbyterian. I went to Sunday school every weekend, and we learned about Genesis, the fact that the universe was created by a God. So I've lived with two mutually contradictory ideas for many years. But with this new theory, we can now meld these two diametrically opposed theories. Now, either the universe had a beginning or it didn't. End of story, right? Nope. There is a common ground. You see, our universe had a beginning. Our universe did have a Big Bang. We live on a sphere, and the sphere is expanding, and that's called the Big Bang Theory. But you see, our sphere, our universe, our bubble universe, exists in an ocean of other bubbles. It is a bubble bath of universes, each universe popping into existence. When these bubbles collide, or these bubbles split off into two bubbles, that's called the Big Bang. That's what the Big Bang is. So then what is the universe expanding into? Children ask that question. They say, Daddy, Mommy, if the universe is expanding, what is it expanding into? Well, you see, we live on a three-dimensional bubble. Insects would live on a two-dimensional bubble, but the bubble is expanding into a higher dimension, and that is nirvana.
Right.
So nirvana, this timelessness, is the larger ocean in which these bubble universes pop into existence and sometimes inflate to create our universe. So you see, with this multiverse idea, which comes right out of string theory, with this multiverse idea, we can combine Buddhism with Judeo-Christian thinking on Genesis, a unified theory of religion. So I think that is aesthetically pleasing, that physics actually has something to say about this. Now, Stephen Hawking had an idea. Stephen Hawking, the late great physicist, said, bah, humbug. There's no God because there was no time for God to create the universe. The Big Bang was like that. The universe suddenly expanded out of nothing, and here we are talking about it. So there's no room for God in Stephen Hawking's universe. But you see, if our universe had a beginning, but there are other universes also being created even as we speak, there are other Big Bangs happening all the time, then there's no problem. There's plenty of time for a God to create a universe because universes are being created all the time. So I see, again, there's no contradiction between religion and science. And also to conclude, Galileo, the great astronomer, was asked that question, and he was put on trial, in fact, for his heretical ideas. And he said the following: what is the purpose of science? The purpose of science is to determine how the heavens go. What is the purpose of religion? The purpose of religion is to determine how to go to heaven. So, in other words, science is about natural law. Religion is about ethics, how to behave, how to be a good person, how to go to heaven. So they're not contradictory because science does not tell you how to become a good person. Right. It's just the laws of how the universe works. Okay. The problem is when people who are scientists begin to pontificate about morals and ethics, or when religious people start to pontificate about natural law, that's where we get into trouble. But as long as we keep these two spheres distinct and complementary, I don't see a problem.
Right. No, definitely. And I think the idea that they can't go hand in hand and like be almost synchronistic with one another, I think is sort of it's a shame that people get into sort of a mindset that you have to be either devout science or devout religion, and you can't have one or two in the other. Like, if anything, like Darwin's theory of evolution, I think could very easily, like, and a lot of like fundamentalist, not to point out specific groups, but a lot of fundamentalist groups don't like the theory of evolution because it goes against the idea God created all man and life. And but I think if you look at that, like theories like that, for example, it kind of almost it could be used as a way to prove the sort of the teachings that it talks about, because I think they really can go hand in hand. And you're speaking about the multiverse and string theory, and I realize maybe we haven't given, like, because a lot of the audience, I don't think, has a specific science background in string theory. And I actually was talking to my grandma before this podcast because she's familiar with your work and she was excited for it, but she said specifically, I don't know anything about string theory. And so, I mean, is there a way you could like define what string theory entails? I know we've already started to dive into that, but is there like a consensus definition of what makes string theory, I guess you could say, in its own sort of a new branch of science, and what sort of that entails?
Okay. Well, if you watch The Big Bang Theory on CBS TV, you know that Sheldon, the great physicist, works on string theory because that's the name of the game. But anyway, go back 2,000 years, back to the Greeks. They had two philosophies of the universe, two theories of everything. Democritus thought that they were atoms that made up the universe, but Pythagoras said, no, it's not atoms, it's music. Because he watched a lyre string vibrate one day, and he realized that the longer the string, the lower the note. And then he went to a blacksmith shop, and he saw the blacksmith banging on a piece of metal. The longer the metal, the lower the note. So he said, aha, mathematics. Mathematics of music can explain the diversities of melodies and the richness of music. So we thought that the universe was basically musical, that all we see around us are different resonances and notes. Now, of course, these theories never went anywhere for 2,000 years, but now we have physics, chemistry, biology, and from that, we can tell that there is a theory, string theory, which says that the universe is made out of tiny, tiny, tiny little vibrating strings, as Pythagoras hinted, and each vibration corresponds to a note. This would be an electron, this would be a quark, this would be a neutrino. Different vibrations correspond to different particles, and that's why we have so many of them. In fact, G. Robert Oppenheimer, father of the atomic bomb, was so frustrated that we were finding so many particles that he said one day, quote, the Nobel Prize in Physics should go to the physicist who does not discover a new particle this year. So each particle, quarks, neutrinos, what have you, are just nothing but musical notes on a tiny string. So what is physics? Physics is the harmonies you can make on these vibrating strings. What is chemistry? Chemistry is the melodies you can play on vibrating strings. What is DNA and life? DNA and life would be a string quartet, ATCG, the nucleic acids of DNA. What is the universe? The universe is a symphony of strings. And then what is the mind of God that Albert Einstein labored for 30 years of his life? What is the mind of God? The mind of God is cosmic music resonating through 11-dimensional hyperspace. That would be the mind of God.
Right. And the idea of, and what you said at the very end there, resonating through 11-dimensional hyperspace. And we're talking about, electromagnetic waves and frequencies. And that's really the basis of like what reality is when you get down to it at the subatomic level. Could you explain different dimensions for the audience? What it, because we live in this dimensional reality, and we talked about this briefly earlier. We mentioned it. But since our sensory perception is so limited, it's possible we're not able to perceive other frequencies. What does that actually mean for what we think is reality? Like, is this sort of an illusion in its own right, just the fact that we think we're physical beings?
Well, first of all, if you think of an ant on a bubble, the ant lives in two dimensions. The ant can move forward, backward, left, right, but the ant lives on a bubble, and the bubble could be expanding. And if you were to ask that ant, what is the bubble expanding into? Well, the ant would say, I don't know. I mean, I can only see two dimensions, forward, backward, left, right, up. The concept of up makes no sense. So when I was a child, I still remember going to the Japanese tea garden in San Francisco. And I'm just watching the carp swimming underneath the waves there. And I said to myself, what would it like to be a fish? And then I realized that fish could only see sideways. They would only go forward, backward, left, right, and that's it. So if there was a scientist fish in that pond, the scientist fish would say, bah, humbug. There's no such thing as a third dimension. The pond is the universe. The pond is two-dimensional, and that's it, folks. End of story. And then I imagine in my childhood youth, reaching down and grabbing the scientist fish, lifting the fish into the third dimension. What would he see? He would see beings breathing without water. He would see beings moving without fins, a new law of physics, a new law of biology. And then I dreamed that I would put the fish scientist back in the pond. What would he tell his fellow fish? He would tell his fellow fish that he just disappeared off the pond, that the pond is not the universe at all, that you can somehow go off the pond into a higher dimension. Now, you may say to yourself, well, what's the benefit of going to a higher dimension? You see, we have four fundamental forces. We have gravity, which keeps us on the ground, the electromagnetic force, which is giving you this internet conversation, and the two nuclear forces, which light up the sun and the stars. But why can't you put them together? Why do we have four? Why don't we have one force? When you put them together, they don't fit. And the greatest minds of the past thousands of years have tried to put together all the forces. There's not enough room in three dimensions to put these forces together. And that's where you need hyperspace. In a higher dimension, these pieces all fit together like a jigsaw puzzle. So I like to think of it this way, that at the beginning of time, there was a crystal. There was a crystal at the beginning of time, like a diamond. But it was unstable, shattered, and all the pieces of the crystal landed on flat land. These people on flat land could not visualize the crystal because their eyes can only see in two dimensions. But they said, let's put it together. Let's put together this diamond with all the fragments. So after many, many centuries, they were able to piece together two fragments. One fragment they called gravity and relativity. The other fragment they called the quantum theory. But they didn't fit. These two gigantic clusters did not fit. And then one day, somebody made the outrageous, blasphemous idea that you could somehow lift one piece into the third dimension and the two pieces would fit together like a jigsaw puzzle. Well, people laughed. They said, what? You can't move in the third dimension. There's no such thing as a third dimension. There's only two dimensions. But in a computer, they could lift the crystal, one fragment, up into hyperspace, and the two pieces fit together exactly. So in other words, the Big Bang was a Big Bang resonating in hyperspace. And we are the two-dimensional fragments of the original explosion.
Right. And so with us being sort of the two-dimensional fragments, do you think in it's possible, and I guess this is more speculation than anything else, it's possible to potentially perceive higher dimensions within our own human experience and actually able to measure that, to to help make particular scientific observations like in string theory and continue this sort of evolution towards finding this theory of everything.
Well, when I was a child, I read about the fourth dimension, the fourth spatial dimension. Time is, of course, the fourth dimension, but the fourth spatial dimension. And I, in my child's mind, tried to leap into hyperspace. So I would do a lot of jumping exercises, hoping to jump into the fourth dimension. But then I realized I couldn't do it. Now I'm a physicist. I work in 11 dimensions. And I now realize that evolution gave us the ability to dodge three-dimensional tigers and three-dimensional lions. But we never encounter a four-dimensional lion or a five-dimensional lion. So evolution never bothered to give us the ability to visualize five-dimensional lions and 10-dimensional horses and things like that. So in other words, your PC effortlessly calculates in hyperspace. Your PC says 3 is not special. Why should 3 be special? Your PC regularly calculates in higher dimensions, but our brain, unfortunately, is a byproduct of evolution. And we can only see pieces of hyperspace. So for example, if a being from a higher dimension were to put his finger into our universe is like a sheet of paper. What would you see if somebody put their finger in our universe? You would see a ring of flesh, because that's all you could see with somebody's finger pointing through your universe. And as you move the finger in and out, the ball of flesh gets bigger and smaller, bigger and smaller. And there's one science fiction story I remember where there was this man who was walking down the street and he bumped into a floating ball of flesh that would pulsate, get bigger and smaller. And then he realized it was somebody's finger poking into our universe. So then he went the other direction. And in the other direction, what did he see? A second ball of flesh. So in other words, somebody from hyperspace was putting 2 fingers into his universe. And at that point, the 2 balls of flesh were getting closer and closer and closer. And then he realized, I'm going to be traveling in a higher dimension. And sure enough, he was grabbed and then lifted into another dimension. And then what did he see? This is a science fiction story. Mm-hmm. What did he see? He would see objects pulsating, getting bigger, smaller, bigger, smaller, because he was floating. He was floating in the 3rd dimension. And if you see a person, what would a person look like in a higher dimension? Well, as a person goes up, you see the person's chest, you see the person's tie, you see the person's face, you see the person's hair, and then he disappears. And so if you were to float in hyperspace, you would see objects continually changing in color, shape, size, which is impossible in our universe. We don't see that happen. Right. How can objects get smaller and bigger and change color and disappear, right? But that's what it would look like if you were to journey in hyperspace.
Right. And it's almost impossible to imagine because we are so constrained within the 3rd dimensional reality that type of, we can
only visualize slices of the real universe. And the real universe is bigger than our limited 3-dimensional senses.
Right, exactly. And I think that's why, we go into the idea that it might potentially be infinite. I mean, this is something you spoke on in depth in the book as well. And, talking about the journey of, or mentioning how typically it seems in science when you come up with an equation and the solution is infinite, that's usually a sign that you need to look again. Do you think the universe, or based on string theory, is the universe in infinite, I guess you could say space of different dimensions? Like, is it something that, and we talk about it continually expanding. Is this idea that it's continually expanding more, meaning that it's so out of our ability to find the end that it could potentially just be infinite, that continual growth?
Well, the short answer is we don't know.
Right.
But we have theories about what the universe looks like.
Mhm.
And the leading theory that agrees with the experimental hard data is a theory called inflation. And inflation says there was a turbocharged expansion at the beginning of time. And the universe is much bigger than we originally thought. It is gigantic. And our telescopes can only see a tiny, tiny little piece of this much larger landscape of universes. Now, is it infinite or is it finite? I like to think that it's finite, but again, you can't prove it. We just know that the universe is a lot bigger than we previously thought. And our telescopes, which probe the speed of light, of course, our telescopes can only go so far. And beyond that is beyond the speed of light. So we cannot see stars that are that far away that they're actually going faster than the speed of light. So our limited senses cannot tell whether the universe is finite or infinite. Sorry about that.
No, right. No, and if anything, I think it's a good it gets into the idea of like, even if the universe is a finite like universe, then we get back into the multiverse theory. It's like, well, this
Mhm.
universe ends, where is what about other universes? So
Mhm.
it's such a grand concept that I personally, I'm not sure that's something that will ever be like definitively solved within our own perception. But then again, maybe it isn't something that's meant to be solved, and something we're just going to sort of continually explore. And
Well, the next question that I usually get asked is, if there's a multiverse of parallel universes, then is Elvis Presley still alive in one of these parallel universes? And the answer is yes. The king could very well be alive in another parallel universe, because in one universe, our loved ones died, passed away, they're no longer here. But there are other universes by vibrating at different frequencies. And in these other universes, people that have died in our universe could very well be alive in another universe. Then the killer question is, why can't we visit them? Why can't we visit a world where people that have died in our universe are still alive in another universe? And the answer, sad to say, is we no longer vibrate in unison with these other universes. We have split apart from them. But yeah, quantum theory says there's a probability that dead people in our universe are still alive in another universe. We call this the cat problem. The cat problem is the biggest paradox in all of science. If you ever figure out the solution to the cat problem, tell me first. We'll
okay.
get the Nobel Prize together.
Sounds like a plan.
The cat problem is you put a cat in a box. In the box, there's a gun. The gun is connected to uranium. Uranium is a quantum mechanical device. It fires or doesn't fire. If it fires, the gun is then cocked and then shoots and kills the cat. Or maybe the uranium didn't fire, in which case the cat is still alive. Before you open the box, the question is the cat dead or alive? Well, believe it or not, when I teach quantum mechanics to graduate students getting their PhD in theoretical physics, I teach them that before you open the box, the cat is neither dead nor alive. It's the sum of a dead cat wave plus the sum of a live cat wave. Now, at this point, you may say to yourself, this is crazy. This is nonsense. You're telling me that before you open the box, the cat is neither dead nor alive? And the answer is, yeah, get used to it. That's how transistors work. That's how lasers work. This conversation is made possible because of this fact.
Right.
And then when you open the box, then of course, you know the cat is either dead or alive. But before you open the box, the cat exists in a parallel state. So how do you then philosophically get your head around that? That you could be two places at the same time, you could be dead and alive simultaneously. The simplest way is to split the universe. This is the multiverse idea, the fact that the universe splits in half. In one universe, Elvis Presley died. In the other universe, no, somebody saved him in the nick of time, and Elvis Presley is still belting out those hits.
Right.
Sounds crazy, right? but it's
Right.
called modern theoretical physics. If you don't like it, sorry about that. That's just
Well,
the way it is.
right. Well, no, and it makes sense because I mean, in reality, you can't prove anything actually exists like in this physical world until it is directly observed. And I think, with the cat problem, like you don't know if it's dead or alive because you haven't seen it. Um, it's not something like you just don't have. There's no way to actually prove it. So I think it speaks to a lot of what we're looking at when we're talking about string theory and looking at the idea of multiverses, and it shows that it is within the realm of possibility. And I think that there's a lot of um, there's a lot of like room for expansion within this field. I mean, how do you like see string theory continuing to evolve in the future? Is it something like maybe it's not in going to be in either of our lifetimes, but do you think that there will be one unified theory that can sort of connect all of this into one? Or is it going to be something that we just continue to work towards and come up with other theories and combine those theories? And it's sort of almost an infinite process.
Well, the short answer is I don't know. Nobody
Right.
knows, but
All
we have
speculation.
ideas and theories. And I think that we will experimentally prove or disprove string theory. For example, we have something called the Standard Model. The Standard Model is a representation of subatomic physics. It's the highest version of the quantum theory. It works. But what's wrong with the Standard Model? Well, what's wrong with the Standard Model is that it's the ugliest theory ever proposed in the history of science.
Mhm.
How can something so fundamental be so ugly? It has 36 quarks and antiquarks. It has about 21 free parameters that you can adjust any way you want. It has 3 generations of identical particles. I mean, it's crazy. It's like getting a platypus, a giraffe, and a whale, scotch taping them together with scotch tape, and claiming that's nature's highest evolutionary achievement. This beautiful, graceful creation called the standard animal. Well, we like to think that the standard model is nothing but the lowest octave of something elegant, beautiful, simple, and that is string theory.
Mhm.
So I got my PhD at the University of California, Berkeley, and I had to memorize the names of all these goddamn subatomic particles, hundreds of particles. To get your PhD, you have to know the names of these particles, right? I would hope that in the future, when a PhD student gets their PhD at the University of California, Berkeley, all they would have to do is say string theory
Mhm.
and get their PhD. Because that says everything. We know the mathematics of strings. We can surmise how they bump into each other. And you don't have to memorize the names of all these goddamn subatomic particles.
Right. Right. No, that makes sense. And, with string theory and with the finding this ultimately equation, it kind of gets it really. I'm very interested in sort of the philosophical ramifications of the universe and sort of the ideas of like what does it actually like mean in terms of having a unified theory of everything, having this sort of God equation. What is your thoughts on? And I know you do talk about this in the book, but what is your thoughts on like in terms of okay, the unit there is let's say that we do prove this unified theory and we have it. What does that mean for us in terms of like okay, we have this, but what is the meaning of the universe itself? Like what is sort of like we have all of this. What does that mean for me and my own sort of purpose within the universe?
Well, people ask that question, what's in it for numero uno? What's in it for me, this unified theory?
Selfish
Well, you
question.
see, every time a new force was unraveled, it changed all of human history. When Newton wrote down the theory of gravity and mechanics, that helped to spawn the Industrial Revolution, a revolution of machines and mechanics. When Faraday and Maxwell worked out the electromagnetic force, that gave us the electric revolution, lit up our cities, created dynamos and generators. And then when Einstein wrote down E equals mc squared, that helped unlock the nuclear force. So now we're talking about unifying all the forces into a grand synthesis. The immediate impact on the average person will be almost zero because we're talking about theories of universes now. So the biggest questions in cosmology would be questions like this: what happened before the Big Bang? What's on the other side of a black hole? Are there gateways to other universes, gateways to other dimensions? Is time travel possible? All these things cannot be proven using the standard model and relativity. You have to go to a higher theory, and that's where string theory comes in. You see, as I said, the universe is a chess game, and we are trying to figure out how the pieces move. But once we figure that out with the equation, the God equation, the next step is to become grand masters of space and time. And we think, therefore, that gateways to other universes, higher dimensions, a multiverse of universes before the Big Bang, that could be resolved. We'll be able to actually solve these questions. Now, the ultimate practical application is this: the universe itself is dying. We know that the universe is going to get colder and colder in the future, perhaps so cold that even life itself cannot survive. So the laws of physics are a death warrant for the universe. But there's an escape clause. The laws of physics have an escape clause. Trillions of years from now, we'll be so advanced that we'll have mastery of something called the Planck energy. The Planck energy is the energy of the Big Bang itself, the energy at which perhaps gateways open up to other dimensions and other universes. When it gets so cold that all life itself begins to perish, at that point, I think that our descendants will create a gateway, a wormhole, a dimensional bridge to a younger universe. So we'll leave our dying universe, which is near absolute zero in temperature, flee to a parallel universe, and then begin to mess up that universe as well.
Oh man, but that sounds like a beautiful journey. Honestly, I wouldn't be surprised if we go and we start messing up some other universes, considering how well we take care of our Earth. But at the same time, that's something that would be so far down the line. It's almost, I feel like our relationship with the Earth, with the universe, would take on almost an entirely new meaning as well.
Well, that's why people think that there could be aliens in outer space that have achieved this energy, because of the fact that our civilization science is only 300 years old.
Right.
The universe is 13.8 billion years old. Plenty of time for advanced civilizations to rise and fall. And by the way, some people email me and say that you don't have to speculate about aliens in outer space because they know they've been there. They've been in these flying saucers. They've been kidnapped by flying saucer people. So I give them some word of advice, and that is, the next time you are kidnapped by a flying saucer, for God's sake, steal something. Steal something. There's no law that says you can't steal from an extraterrestrial civilization. You're not going to go to jail, and then you'll have proof
Right.
that you were there. An alien chip, an alien pencil, whatever.
Right. Yeah. Then that would give proof to the claims. Absolutely. And you're definitely right in the sense that I think people, I think in a general sense, like I come from an education background, and I've noticed that like in history, like when we teach history, for example, a lot of civilizations, like leaders kind of think they've reached the pinnacle of existence, but in particular fields like science, it's sort of what I appreciate is that there is sort of the continual recognition that we're still growing, we're still evolving. Like there isn't like a finite ending that we've reached in just thinking because we've found a new equation or a new theory that this is the theory to top them all per se. Like and so it's I think people can get lost in the needing the instant gratification of like, I want all the answers to every single theory like right now. And that's, maybe that's something we've been conditioned into, but It's
Well, you see, that's where physics comes into play again, because we physicists actually seriously think about what it would be like to communicate with radio or whatever with very intelligent civilizations in space. So we rank them as type 1, type 2, and type 3. A type 1 civilization is truly planetary. They know everything about energy on their planet. They control volcanoes, the weather. They control the weather. That's type 1. Type 2 is when they control the energy of the stars. The entire output of a star they use to energize their machine, like Star Trek. Star Trek would be a typical type 2 civilization. Then there's type 3. A type 3 civilization is galactic. They harness the entire energy of a galaxy. And then the question is, what are we? On this scale of energy, do we have the energy of an entire planet controlling the weather and volcanoes? Do we have the entire output of a star? Do we play with galaxies and roam the galactic space lanes? No, we're type 0. We get our energy from dead plants, oil and coal. But we can dream. We can dream of the day when we become type 1, type 2, and type 3. You see, we're on the verge of becoming type 1.
right.
We see the birth pangs of a type 1 civilization everywhere you look. What is the internet? The internet is the beginning of a type 1 telephone system. We are privileged to be alive to witness the birth of the first type 1 technology, the internet. And the internet itself will eventually become BrainNet. We will communicate mentally, just like we do with animals today. Believe it or not, we can now record memories. Memories can now be recorded in animals and then put on the internet. And we're seeing the birth of a type 1 language already on the internet. What are the languages people speak? Mainly English and Mandarin Chinese. We're seeing the beginning of a type 1 language. A type 1 sports, the Olympics, type 1 fashion, Gucci, Chanel, and type 1 music, rock and roll, for example, or classical music. And so we're seeing the beginning of a new civilization emerging right before our eyes, a planetary civilization, perhaps by the year 2100. Perhaps by 2100, we will be type 1.
Right. No, and definitely. And you see all of the advancements in artificial intelligence and the advancements in, the things that SpaceX is doing and Elon Musk and all of the different, um, the technological, like 20 years ago, talking about these things, it may have almost been um, unheard of if you said, like maybe right before the internet, before that was a massive technology, it would have been unheard of to sort of make that sort of suggestion. And I feel like the rate of progress as you continue advance actually only continues to accelerate in terms of the amount of progress that you can make. Because technology, new technology, like what has the internet brought us? It brought us an entire new wave of technologies that we couldn't have imagined pre-internet. So it's the idea of type 1 civilization is for me, I see that and I'm like, it's exciting because it gets into that idea of like we can, getting back to just talking about the universe as a whole, we can eventually, as a species, uncover the true nature of the universe through our sensory perception, through experiencing and harnessing like galactic power and having that um, like in our actual awareness and livelihoods, like being type 0. I think it's like, all right, we're the foundation right now, and how do we continue to build on that? And that it's an exciting prospect.
Right. Now, so far, we've talked about solid physics that in principle can be reproducible, falsifiable, and testable. That's
Yes.
solid science. Now, let me speculate. Let me
All
stick my neck out a little bit. The question is, how will we explore the universe in the future? Well, we're in the process of digitizing people. People can also be digitized, their personality, memories, emails, Instagram, pictures. There's a company in Silicon Valley already offering to digitize everything known about you. In the future, we'll be immortal. We'll be digitized. I would love, for example, to go to the library and talk to Einstein. Somebody will digitize Einstein. all his papers, all his mannerisms, all his movies, and create a realistic copy of the man. And we could become immortal too, where everything known about us is digitized. Now, what are we going to do with that digitized information? First, we'll live forever. Second, we'll put it on a laser beam, because information can be placed on a laser beam, and we're going to shoot it to the moon, to the stars. In 1 second, you will be on the moon. In 20 minutes, you'll be on Mars. In 4 years, you'll be among the stars, the Alpha Centauri system. And I think that's our future, in the sense that we're going to explore the galaxy at the speed of light, because our digitized beings will be put on laser beams and will laser port ourselves throughout the universe. And now let me stick my neck out. I think this already exists. I think the aliens, they don't use rockets. They don't have to worry about weightlessness and gravity and atmospheric problems and accidents. No, they're pure energy. They've digitized themselves, shot themselves with laser beams throughout the universe at the speed of light. So for example, let's say you want to go to the moon. In 1 second, your digitized soul is on the moon. It's downloaded into a mainframe on the moon, and your personality is put into an avatar. Your avatar is superhuman. Your avatar is super pretty, super handsome. You can live on the moon. You don't have to breathe air, because your avatar is a robot. Super strong, super beautiful, what have you. And you'll explore the universe this way. Each time you go to a different planet, you'll download yourself into an avatar that could survive in a hostile gravity, hostile atmosphere. So I think that maybe next to the Earth, maybe not too far from the Earth, there's a highway, a laser highway, where the souls of billions of digitized beings basically laser port themselves throughout the universe. Now, the sad thing is that we are so stupid, we are so primitive, that we're totally unaware of this, blissfully unaware, and can't even prove it. I mean, the technology necessary to find a laser highway in outer space, that's beyond our primitive type 0 technology.
Right. Right. We're like how if sort of higher energy beings looked at us, it would be like us looking at like chimps or some other species that we would find in like the rainforest. That's sort of where we're at in our.
They'll say, what? You're so primitive. You're not digitized yet. You can't move at the speed of light. You can't put yourself into an avatar of any shape, size, or form. So primitive. You're stuck as a Homo sapien.
Right. Then we're grounded to Earth for the immediate future, because that is like a long. I definitely agree with what you're saying though, and it actually resonates, because I feel like it. Like, what is our natural like essence? I guess you could ask the question, and I think it is like pure energy anyways, like our souls are. And that almost feels like a if we're looking in the long term like form of evolution, like how do we optimize that essence of our energy and like who it is that we are and what we're meant to do and explore. That feels like the long term like almost a return to like the true home in a way. Like the Earth doesn't have to be the only home. Like it's all part of, like we're part of all of it essentially. So it's it feels like a right natural step, even if it's years and years and years and years away. And hopefully humanity doesn't screw it up in the meantime. But
You see, the problem with science fiction is that it takes ordinary society of, let's say, the 1950s and simply multiplies by 1 million. But it's the same 1950 society, the same social structure, the same people, except, of course, they have super rockets, right? What I'm saying is open your mind to the possibility of a computer revolution where we digitize ourselves, in which case we're no longer bound by the restriction of our three-dimensional bodies. We become immortal. We can load ourselves into avatars, become super powerful. We become the gods that we used to fear when we were primitive, because the primitive beings used to fear the gods that can control the weather, that can do all these things, we will become, in some sense, the gods of our ancestors.
Right. No, definitely. And that's I feel like that's almost what it's all about. The return to like expansion, growth, and that possibility. Obviously probably not going to happen in our lifetimes, but you know, the ancestors down the line, or like the generations below, they can listen to this 100 years from now and they'll be like, they didn't even have a clue where we were going, but they're on the right track. But they'll I don't know. It gets me excited because I think that's a real possibility. Like they're like,
All I'm saying is open your minds to what the laws of physics can really present, and just realize that science fiction takes ordinary Homo sapien society and multiplies by 1,000,000. That's it. The same society, the same problems, the same psychological conflicts multiplied by 1,000,000. What I'm saying is there could be a tremendous leap in the way we deal with artificial intelligence, the way we deal with digitization, the way we deal with space travel. Totally new framework. That's what we need.
Right. No, that makes sense. So, I mean, I'm excited to see if that new framework actually develops in our lifetime as well, and sort of if we can sort of redefine that, because I think it's important if we want to make a leap. So, Dr. Kaku, I know we're approaching an hour, and you want to be mindful of your time. So, your new book is available now. Where could people go to find it? Sort of interact with the work you're doing, and where you'd send them.
Well, go to my website and you'll see a link where you can order the book. Book comes out April 6th, and it's a book for everybody. It's not a book for physicists. It's not a book for engineers. It's not a book for people who are super religious. It's a book for everybody. That's why I wrote the book, so that it's accessible to the average person who has no understanding of physics, no understanding of the world other than having curiosity. So this book is for the curious, the people who want to know, what is it all about? I mean, the labors of thousands of scientists, right? All of them, in some sense, struggling to find meaning, to find a theme, to find a paradigm by which to explain the entire universe. That is the God equation.
Right. And I definitely attest to the book that I'm very a curious, inquisitive person, and it definitely quenched that thirst, you could say. It was very well written, and I think it's accessible for a lot of people. So I'm excited to see the reception behind it, and I'll obviously put a link to your website into the book in the episode description.
mkaku.org.
Right.
I'm also on Twitter, and on Facebook we have 4.5 million fans on Facebook.
Oh wow. That's a big audience. A lot of people ready for this book then. And I'll make it accessible and have the links to all of that in the episode description. People can scroll on down, click it. It's right there, especially if they don't feel like typing something out. They're feeling a little lazy, and they're just right there for them.
Right.
So Dr. Kaku, thank you so much for taking the time to come on the podcast. It was truly an honor to get to speak with you. And, I truly enjoyed your book, and I hope the audience resonated with the podcast and, goes and buys it for themselves.
Okay. Let's hope so.
All right. And I'll send on the podcast link when I have it out. I'll make sure that I put it out after the week of the book coming out, which is next week, but I'll plan to release the episode on Wednesday or Thursday of next week, and have it out then.
Okay. Sounds good.
All right. It was great to talk to you. Enjoy the rest of your day.
Okay. Same to you.
All right. Bye.